Hello everyone, my name is V. Hasini. Today I am going to present on stack operations. This presentation explains how stack works and their operations. A stack is a fundamental data structure. It is used to manage memory and control program flow. It works using a simple principle called LIFO. Stack follows LIFO, last in, first out. The last element added in the first one removed. Example, stack of plates. You remove the top plate first. Imagine a stack like plates in a cafeteria. You can only add from the top, remove from the top. This makes operations simple and controlled. Stacks can be implemented in two ways: array representation, linked list representation. Both methods store elements but work differently internally. There are five main operations: push, pop, peek, is empty, is full. These operations control how the stack works. Let's see these operations in detail. Push operation. The push operation is used to insert a new element into the stack. The element is always added at the top position of the stack. Since stack follows LIFO, last in, first out, the latest inserted element becomes the first to be removed. Stack has a pointer called top. Top keeps track of the last inserted element. Initially, top equals to -1, which means stack is empty. When push operation is performed, first it checks if the stack is full. If it is not full, it increases top by 1. Insert the new element at top position. According to the algorithm, step 1, if it checks if the stack is full. Step 2, if it is full, it gives stack overflow. Step 3, if the stack is not full, it increases a top by 1 and it inserts an element to the top of the stack. Here is an example on push operation of the stack. Here we give an example of a stack 10, 20, 30 which is at initial. Now we are pushing an element 40 which is a new element we are pushing into the stack. It becomes 10, 20, 30, 40. And here the 40 is the new top element of the stack. Pop operation in stack. The pop operation is used to remove the top element from a stack. Since stack follows LIFO, last in, first out, the last inserted element is always removed first. Stack uses a pointer called top. Top always points the last inserted element. When pop operation is performed, the element at the top is removed. Top is decreased. When pop operation is performed, first it checks if the stack is empty. If the stack is empty, it stores the top element, decreases top by 1, return the removed element from the stack. According to the algorithm of pop operation, first it checks if the stack is empty. That means top equals to -1. If the stack is empty, it shows stack underflow. If the stack is not empty, it stores the topmost element of the stack and decreases the top, which means top -1, and it returns the element by deleting it. Pop operation example. Initially, stack is 10, 20, 30. Here, the top is index of 2, which means 30 is the top. After pop, the, the element stored is 30 in the item. After storing, the top becomes index of 1, which means the element 20. Now the element 30 is removed and the stack becomes 10 and 20. This is the pop operation in stack. Peek operation in stack. The peek operation is used to view or access the top element of the stack without removing it. It allows us to check if the current top element while keeping the stack unchanged. Stack uses a pointer called top. Top always points to the last inserted element. In peek operation, we only read the element at the top. We do not modify the stack. When peek operation is performed, first it checks if the stack is empty. If the stack is not empty, access the elements at top and returns the elements. Stack remains exactly the same. The stack doesn't change. According to peek algorithm, step 1, it checks if the stack is empty or not. If the stack is empty, it stops and gives stack is empty. If the stack is not empty, it gives error. If the stack is not empty, the top element of the stack is stored in the item and it returns the item which is the top element of the stack. Example for peek operation. Initially the stack is 10, 20 and 30. The top element of the stack here is 30. So now it returns the element 30. After the operation peek is performed, the stack remains unchanged and gives the same 10, 20 and 30. The next operation in the stack is empty. Here it checks whether the stack is empty or not. It consists of elements or not. From the algorithm, we know that top equals to -1, which indicates that the stack is empty. If top equals to -1, it returns true, which means stack is empty, or else it returns false in the case of top equals to 2, which means stack is not empty. Here is the clear example of stack operation on isEmpty. When the top equals to -1, it shows the stack is empty. Whereas in other case of top equals to 2, it shows that the stack has the elements and it is not empty. The last operation in this stack is full. IsFull is an operation performed in stack to check whether the stack is full with elements or not. It is used to prevent the overflow of the stack. According to the algorithm of isFull operation, it checks whether the top equals to max minus 1. Max is the maximum amount of the stack which is given. If the top equals to max minus 1, it returns true, which means the stack is full, or else it returns false, which means the stack is not full. Here is the example of isFull operation of stack. Here, given that maximum is 5, when the top equals to 4, this means that stack is full and it has the elements. When the top is 2, it means that stack is not full and we can insert the elements. This is the representation of stack using arrays. In the similar way, we can represent the stack elements using linked list. These are the operations held in stack using arrays. Thank you.